Our next type of reaction are substitution reactions. This is where we replace either a hydrogen atom or a functional group with another functional group. Okay? And so we form two compounds, and usually we require two reactants. So for example, we can have an alkane react with a halogen, and I could get an acyl halide. Now, alkanes are very stable, so this is reaction, therefore, is not likely to proceed easily, so I have to have UV and often a catalyst. When this reaction occurs, I'm going to get a hydrogen halide as a waste product. Now, if I were to perform this reaction with excess halogen, then I could replace more than one hydrogen on my alkane. And of course, I get my hydrogen chloride waste. I could take a acyl halide and react it with a strong base, and this would give me an alcohol, where the OH would be replaced, and I get a waste of the halide ion. And we could have the reverse reaction with an alcohol reacting with a strong hydrogen halide acid. So for example, with HCl or HBr, and we would get the reverse reaction as to what we just did above, where the OH would come off and we would get a waste of water. And I'd replace the hydroxyl group with a halogen. A common reaction that we do is we will react an ammonia or an amine with an acyl halide. And the reason we do this reaction is this is how we make our amines, or we make our secondary or tertiary amines. Okay, so if I have an acyl halide react with ammonia, then what will happen is that the halogen will come off and it will attach my amine group, giving me a waste of a hydrogen halide. But I could take this, what we would call up here my primary amine. It's called a primary amine because I only have one acyl group on it. And I could react it with another acyl halide, and that would give me a secondary amine. And then I could take my secondary amine and react it with an acyl halide, and it would give me a tertiary